Okay, this could be the holy grail that will free us from our dependence on China. China has quietly controlled the battery world while the United States and Europe have been stuck trying to catch up. That is not speculation, it is reality. Even today, most electric vehicles on American roads still rely on battery technology that comes from China. But now the story is starting to shift. Something unexpected is happening inside the United States. A US-based company has just revealed a new battery that many engineers are already calling a major breakthrough. It is not solid state, and it is not a traditional lithium-ion battery either. It sits somewhere beyond both, and its performance numbers have left even longtime industry experts genuinely surprised. This battery is built to last longer, operate reliably in extreme cold, charge at remarkable speed, and deliver an extraordinary energy density of up to 660 watt-hours per kilogram. In simple terms, that kind of density could allow an electric vehicle to travel close to 1,000 miles on a single charge. And here is the part that really changes the conversation. This battery is being manufactured in the United States, which means companies like Tesla could potentially gain access to it in the future. This is not internet hype or rumor. Sandy Munro, one of the most respected voices in electric vehicle engineering and battery analysis, personally visited the factory, saw the technology with his own eyes, and openly praised what he witnessed. Not long after his visit, the company received a major global innovation award recognizing the same breakthrough. So, does this mean the United States has already beaten China in the global battery race? Not yet, but for the first time in a long time, the idea no longer feels impossible. So what exactly is this technology, and how close are we to seeing it inside real electric vehicles? Let's take a closer look. The battery technology we are talking about today is a semi-solid lithium-ion battery developed by a company called 24M. 24M, short for 24 Molecular, is a battery technology company based in Cambridge, Massachusetts. For years, the company has focused on rethinking how batteries are built from the ground up, targeting the industry's biggest challenges including high cost, safety concerns, limited energy density, and recyclability. What truly sets 24M apart is not just the chemistry, but the manufacturing process itself. Traditional lithium-ion batteries depend on extremely complex production lines. Electrodes must be coated, dried, cut, stacked, or wound, and aligned with extreme precision. If even small tolerances drift, the risk of dendrites, internal shorts, and long-term degradation increases dramatically. 24M takes a completely different approach. Their proprietary manufacturing method, known as Live Forever, removes much of that complexity. Instead of layering dry materials with binders, 24M mixes the active material directly with the electrolyte to form a thick semi-solid slurry. That mixture is then cast directly onto metal foil. The impact is significant. This method reduces manufacturing steps by roughly 50%, lowers capital equipment costs, cuts energy consumption, and allows for much thicker electrodes. The result is higher energy density, improved safety margins, fewer failure points, and a production process that is far more scalable and sustainable. And this is not just theory. Real-world testing has already shown energy densities reaching up to 660 watt-hours per kilogram, far beyond the roughly 400 watt-hours per kilogram threshold considered critical for advanced electric vehicles, aerospace systems, and next-generation electric aircraft. Lighter batteries with that level of density do not just increase driving range. They improve efficiency, reduce system weight, simplify thermal management, and lower overall vehicle cost. In other words, this is not simply a better battery, it represents a fundamentally different way of building them, and that is exactly why the industry is paying attention. You've probably heard about solid-state batteries before. Most people have. Simply put, solid-state batteries replace the liquid electrolyte in today's lithium-ion cells with a solid one. The electrolyte is the material that allows ions to move between the anode and cathode while charging and discharging. An easy way to imagine it is this. If a lithium-ion battery is like a sandwich with only sauce in the middle, then a solid-state battery is one with real filling inside. But here's what makes this interesting. 24M's battery is not solid state, yet it can add around 200 miles of range in just 4 minutes. And unlike ultra-fast systems that require expensive megawatt chargers, this one works on standard 400-volt or 800-volt charging systems. That means faster charging without massive new infrastructure. With an energy density reaching 660 watt-hours per kilogram, this battery could easily push electric vehicles past the 1,000-mile range mark. In fact, CATL has already confirmed that even 500 watt-hours per kilogram is enough to reach that level. That number matters more than people realize. 1,000 miles means drivers could cross multiple states without stopping. Gas cars typically travel only 400 to 600 miles per tank, so at that point, EVs are no longer catching up. They're moving ahead. And when you combine that with adding 200 miles in 4 minutes, one of the biggest reasons people hesitate to buy EVs, charging time, starts to disappear. It's no surprise this technology just won Best Technology of the Year. While solid-state batteries promise high energy density, they remain extremely expensive and still face degradation issues. That's why 24 million chose a different direction. Instead of solid electrolytes, they developed a new liquid electrolyte called Eternalyte. This electrolyte dramatically improves fast charging and performs exceptionally well in cold weather. In tests, 24 million cells retained nearly full performance at 0 degrees Celsius, and more than 80% even at minus 40 degrees Celsius, something conventional lithium batteries simply cannot do. Eternalyte also offers about 3 times the ionic conductivity of standard electrolytes, allowing ions to move faster and enabling charging speeds up to 4 times quicker. The key advantage is flexibility. This electrolyte can be used across many lithium-based batteries, including formats like Tesla's 4680 cells. According to 24M, it can be integrated into existing production lines without major changes. When combined with the company's Impervio separator, safety improves even further. Impervio acts like a built-in circuit breaker, suppressing dendrites and detecting early internal faults before thermal runaway can occur. That technology alone just won Fast Company's 2025 World-Changing Ideas Award. Today, the world is seeing more breakthrough battery technologies than ever before. Every year, we hear about higher energy density, faster charging, safer materials, and bold laboratory results that promise to change everything. On paper, many of these technologies look revolutionary, but the hard truth is this: most of them never make it beyond the lab. Building a working prototype is one thing. Producing millions of cells year after year with consistent quality, safety, and cost control is something entirely different. That's where most battery breakthroughs fail. Manufacturing complexity, supply chain limits, equipment costs, and reliability over thousands of charge cycles often stop these ideas long before they reach real vehicles. Now, we want to hear from you. Do you think batteries like this could finally remove the biggest barriers to EV adoption, or is there still something holding electric vehicles back?